Hello students, welcome back to today's class on coordinate geometry, and in today's class we're going to discuss some applications or practice questions based on all the topics that we have discussed till now, right? My name is Avinash and I'm a graduate from IIT Kharagpur. Let's start today's session. So what is the first question we are discussing here today? Find the distance of the point minus 6,8 from the origin. Yesterday we have discussed the same thing. We discussed the same question yesterday in the last slide. Let's try to solve once again. We discussed the distance between 2 points formula. Distance between 2 points x1 y1 and x2 y2 is equal to root over x2 minus x1 whole square plus y2 minus y1 whole square. X2 minus x1 whole square plus y2 minus y1 whole square. Okay, the distance of the point minus 6,8 from the origin, minus 6,8 from the origin 0, 0. So let's try to see what is the distance. That is root over x2 minus x1, 0 minus of minus 6, 0 minus of minus 6 whole square plus 0 minus 8 whole square. So minus of minus 6 square is 36 plus 8 square is 64. 36 plus 64 will give you root over 100, and root over 100 is 10 units. Okay, so that is the distance between these two. Let's try to see the next question. Two of the vertices of triangle ABC are given as 6, 4 and minus 2, 2, and its centroid is given as 3, 4. Find the coordinates of the third vertex C of the triangle ABC. Right? So please try to solve that quickly. Try to recall what is the formula for centroid of the triangle when the vertices are given. Right? So please try to do it fast. Last 10 seconds. Right. So let's try to see what is the answer here. Okay. So what is a centroid? First of all, let me recall. Let me tell you what is centroid, and then we'll try to tell what is the formula for that. Centroid of the triangle ABC is a point of intersection of medians, point of concurrence of medians. So what is the median? Median means the line which is passing from the vertex to the opposite side midpoint. To the opposite side midpoint. If this is the midpoint, so this is the median. Okay. So in the same way we have one more median here and one more median here. Right. So this will give you this point of concurrence which is represented with centroid G. Which is Z, which is centroid. Right. So now to find the centroid of the triangle formed by three vertices x1 y1, x2 y2 and x3 y3. So the value of the centroid Z is given as x1 plus x2 plus x3 by 3 comma y1 plus y2 plus y3 by 3. x1 plus x2 plus x3 by 3 comma y1 plus y2 plus y3 by 3. So 6 minus 2 plus what is the third vertex? We don't know what is the third vertex. Let's try to leave it as it is by plus x3 by 3 comma y1 plus y2, 4 plus 2 plus y3 by 3. So this will give you the value 3, 4. That is the centroid. So now you need to compare these two to get the value of x and these two to get the value of y. So let us try to see that. 3 is equal to 6 minus 2, 4. 4 plus x3 by 3. So 3 this is a 9 is equal to 4 plus x3, and we have x3 is equal to 9 minus 4 is 5. x3 9 minus 4 is 5, right? The same way here 4 is equal to 4 plus 2 6, 6 plus y3 by 3. 4 3 is a 12 is equal to 6 plus y3, and we get y3 is equal to 12 minus 6 is 6, right? So the point is 5, 6. The third vertex is 5, 6. Once again, please cross check that. You may get some calculation mistakes here. Calculation mistakes in mathematics are quite possible, but you should not repeat that in your examinations, right? So please do it properly and we'll move forward for the next question. The perimeter of triangle with vertices 0, 4, 0, 0 and 3, 0. We need to find what is the perimeter, not the area. Okay, what is the perimeter? I'll also discuss about the area for the same question. So please try to do it soon. So in the same question, I'll also tell you how to find the perimeter as well as area. Please try to quickly find the answer. It will be very, very simple. It's better if you can draw the graph or plot the points on a graph paper, and then you can try to find the area. So it will be very simple. Trying to find the perimeter. Last 20 seconds. Right, so let's try to see what is the answer here. Okay, the perimeter of triangle with vertices 0, 4, 0, 0 and 3, 0. Perimeter, let me try to plot these points in the graph paper. I'll tell you it's the most easy method. Okay, so the point 0, 0 will be here. I hope you already know how to plot the points on the graph paper. So 3, 0 is a point on x-axis at a distance of 3 units, and 4, 0, 0, 4 is a point on y-axis at a distance of 4 units. So this is the triangle that we are going to discuss. Okay, so this is the triangle that we are going to discuss now. Now to find the area of this triangle or the perimeter. Perimeter is very simple, right? For example, this 3 units, 4 units using Pythagoras, or trying to find the distance between these two points, you can say that the distance between these two is equal to 5. Okay. So distance is equal to root over 3 minus 0 whole square plus 0 minus 4 whole square. X2 minus x1 whole square plus y2 minus y1 whole square. So 3 square 9 plus 4 square 16. So which is a root 25, which is a 5. Root 25, which is a 5. Or you can also use Pythagoras theorem here. Okay, if you take it as x, so x square is equal to 3 square plus 4 square. So x square equal to 9 plus 16, which is 25. So x is equal to 5, right? You can use Pythagoras theorem, or you can use the distance between the points. So you'll get 5. So now tell me, what is the perimeter of this figure? Perimeter 3 plus 4 plus 5. Perimeter means sum of all the sides. 3 plus 4 plus 5. 3 plus 4 7. 7 plus 5 is 12. 7 plus 5 is 12, right? 12 centimeters. And now my question is how to find simply the area after getting to here. Area of right angle triangle, you can see here, right angle triangle. This is the right angle, right? Area of right angle triangle, you can take it as half base into height. Area of any triangle, you can, not only right angle, half base into height, but height should be there whenever you're discussing. So half into base, you can take it as 3, and the height of the triangle is taken as a 4. So 4 into 3, 12, 12 by 2 is 6 centimeters square. The area of triangle is 6 centimeters square, 6 centimeters square. Or it is not, if it is not centimeters, it is unit. Okay, area is 6 units square. The perimeter is 12 centimeters, right? So moving forward for the next question. The area of triangle, the same question we are discussing. The area of triangle with the vertices, okay. So area, you can discuss with 0, 0, you can discuss with 3, 0, another point is 0, 4. So this is 3 units, 4 units, half into base into height, that is 12 by 2 is 6 units. Now, let's say you don't know all these things. Let's say you don't know all these things, or some other vertices are given. Then you may ask me, sir, how to do this type of questions, sir. Okay, so for that we have a formula with all the vertices. Area is equal to half x1 into y2 minus y3 plus x2 into y3 minus y1 plus x3 into y1 minus y2. So this is how you can try to bring x1 y1, x2 y2 and x3 y3. x1 y1, x2 y2 and x3 y3, right? So half times of x1 0 into y2 minus y3, 0 minus 0, plus x2, 0 into y3 minus y1, 0 minus 4, plus x3, 3 into y1 minus y2, 4 minus 0. Right? So that will give you half times of 0 plus 0, and this again plus 0 into some other number 0, and this is plus 3 into 4 is 12. So that will give you 12 by 2, 12 by 2 which is 6. 12 by 2 which is 6, and we don't have any units, so it is unit square or square units. You can write 6 square units. Always remember that area will be mentioned in square units only. Area will be mentioned in square units only, right? A very beautiful approach. Let's try to move forward for the next question. Once again, yeah. Right. If A and B are 1, 2 and 6, 7 respectively, find the coordinates of P on AB such that AP is equal to 4 by 5 times of AB. Right. So please try to do it fastly. AP is equal to 4 by 5 times of AB. 1 minute. Please try to solve that as fast as possible. If you need more time, I can give you more time for this question. Last 20 seconds. Last 5 seconds. Right, so time is done. So let's try to see that. So how to get this? 1, 2 and 6, 7 are there. 1, 2 and 6, 7. So now what is the relation given? This is A, this is B. So now we need to find a point P such that AP is equal to 4 by 5 times of AB. AP is equal to 4 by 5 times of AB. What is the meaning of that? That means you can say AP will be, out of the total 5 parts, you need to get 4 parts. Okay. So see carefully here. AP is, if this is 4 parts, AP, the total should be 5 parts. This AP by AB is equal to 4 by 5, correct? AP by AB is 4 by 5. So if AP is 4 parts, not exactly 4 units or 4 centimeters, 4 parts, the total AB should be 5 parts. That means the leftover PB is 1 times. The leftover PB is 1 time. That means, so we can say 4 is to 1. The ratio is 4 is to 1, not 5 is to 1 or not 4 is to 5. Right? So we need to find a point P which divides A and B in the ratio 4 is to 1, and tell me how to get the point. What is the formula for that? What is the formula for that? M is to N. If the ratio is M is to N, M x2, this is x2 y2, and this is x1 y1. Okay. M x2 plus N x1 by M plus N, comma, M y2 plus N y1 by M plus N. mx2 plus nx1 by m plus n, comma, my2 plus ny1 by m plus n. So mx2, 4 times of 6, 6 4s are 24, plus nx1, 1 times of 1 by m plus n, 4 plus 1 is 5, comma, my2, 4 times of 7, 7 4s are 28, plus ny1, 1 times of 2, 28 plus 2 by m plus n is 5, right? So 24 plus 1, 25. 25 by 5, comma, 28 plus 2, 30 by 2. So that will give you 5, comma, 6. 5, comma, sorry, this is 5. 5, comma, 6. 5, comma, 6 is the point which divides A and B in the ratio 4 is to 1, such that AP is equal to 4 by 5 times of AB, right? This is a very simple, a very beautiful approach. From the 4 by 5 relation, you need to find the ratio. You need to find the ratio, right? So what is the next question? What is the next question we are having? Find the coordinates of the point of trisection of the line segment joining the points minus 10, 2 and 20, 5. Points of trisection. What do you mean by that? Points of trisection means which divides that A and B into 3 parts. A and B into 3 parts. So 1, 2, 1, 2 and 3. 3 equal parts. So we can say that A and B is here. So if this is one part, this is one part, this is one part. Let us say this is point P. P divides or AP by PB. AP by PB, this is one part, PB is two parts. That means P divides in the ratio 1:2. P divides in the ratio 1:2. What about the other point Q? Other point Q, which is a AQ by QB. AQ is 2 units by QB is 1 unit. So this Q divides it in the ratio 2:1. AP is 1:2 and P divides in the ratio 1:2 and Q divides in the ratio 2:1, right? So now let's try to move forward. Find the coordinates of the point of trisection of the line segment joining the points A minus 10, 2 and B 20, 5. Okay, so let's try to see once again. Let me erase all this. So let's try to find point P so that you can try to find point Q later. Okay. So A is given as minus 10, 2 and B is given as 20, 5. Okay. So now tell me what is the formula? If this is M is to N, x1, y1, x2, y2. The point is mx2 plus nx1 by m plus n, comma my2 plus ny1 by m plus n, mx2 plus nx1 by m plus n, comma my2 plus ny1 by m plus n. Okay, so that will give you mx2. Let me take that, right. Yeah. So mx2. So 1 into this is x2, 1 into 20 plus n times of x1, 2 into minus 10, 2 into minus 10 is again minus 20 by m plus n 3, comma my2, 1 times of y plus n y1, 2 times of 2, 4 by m plus n is 3. So 20 minus 20 is 0, 0, 5 plus 4 is 9, 9 by 3. So it is 0, 3. It is 0, 3, right? That is the answer. Find the coordinates of the point of trisection of the line segment joining A and B. So one point is 0, 3. The other point you need to find. So which divides that in the ratio 2:1. Which divides it in the ratio 2:1. Right? So let's try to move forward to the next question. The point Q. You need to still find the point Q. We got the point P. Okay. So the next question. Find the slope of the line passing through the points A and B. We have 2 points. And now tell me, what is the line joining 2 points formula? We discussed previously. The slope is equal to y2 minus y1 by x2 minus x1. So this is x1 y1 and this is x2 y2. So y2 minus y1, 3 minus 4 by x2 minus x1, 4 minus of minus 2. So 3 minus 4 is minus 1. By 4 minus of minus 2 is 6. 4 plus 2 is 6. So that will give you minus 1 by 6 as a slope. Slope of the line joining 2 points y2 minus y1 by x2 minus x1. Right? Moving ahead. Determine x so that minus 5 is the slope of the line passing through P and Q. Just now we discussed the slope m is given as y2 minus y1 by x2 minus x1. So this is x1 y1 and this is x2 y2. So y2 minus y1, 24 minus 19. 24 minus 19 by x2 minus x1, that is x minus 20. 24 minus 19 by x minus 20. y2 minus y1 by x2 minus x1, right? So determine x so that minus 5 is the slope. So 24 minus 19 is 5. 24 minus 19 is 5 by x minus 20. X minus 20 and this value is given as a slope as minus 5. Correct? Once again, let's try to see that. y2 minus y1 by x2 minus x1 is given as minus 5. Right? So 5 by. So now transform this side or do the reciprocal. X minus 20 by 5 is equal to minus 1 by 5. Right? X minus 20 by 5 is equal to minus 1 by 5. So 5 and 5 can be cancelled. Here also, you can directly cancel these two. So x minus 20 is equal to minus 1. So x is equal to minus 1 plus 20. So x is equal to 20 minus 1 is 19. X equal to 20 minus 1 is 19, right? So from there we'll get the answer. The slope is minus 5. Clear? So moving ahead for the next question. Find the area of the triangle whose lengths of the sides are 6 meters, 3 meters and 5 meters by using Heron's formula. So what is Heron's formula? You know that, right? Heron's formula is given as delta is equal to root over s into s minus a into s minus b into s minus c, where s is equal to semi-perimeter. I told you semi-perimeter, which is a plus b plus c by 2. That is a semi-perimeter. So first of all, let's try to find what is S. 3, 5 and 6. 3 plus 5 plus 6 by 2. 6 plus 5 is 8. 8 plus 6 is 14. 14 by 2 is 7. Once again, let me check that. Right? So 6 plus 3 is 9. 9 plus 5 is 14. So 14 by 2 is 7. Correct? So that will give you root over 7 into S minus C. 7 minus S minus A, the first side 6 into 7 minus the second side 3 into 7 minus 5. So let us solve that. Root over 7 into 7 minus 6 is 1. 7 minus 3 into 4. 7 minus 5 is 2. So 7 4s are 28. 28 2s. 7 4s are 28. And 28 2s are 56. Okay. You can, 56. I don't think you can further solve that. You can just leave that as it is. So area of triangle is root 56 square units. Root 56 square units. Okay. So Heron's formula is very, very important when you're trying to find the area of the triangle. Clear? So we have one or two more questions that you can try. Find the centroid of the triangle whose vertices are. Okay, I'm not going to do that. X1 plus X2 plus X3 by 3, Y1 plus Y2 plus Y3 by 3. Straightforward question. Okay. So, and we have one more question. Find the area of the triangle whose one vertex is origin and the other 2 points are at a distance of 5 units with the origin on either of the axes. Okay. So please try to read the question, understand the question and try to do it. Very beautifully framed. You need to understand the question first of all and then you can try to proceed. Okay. So we have further couple of questions. Find the value of K for which the points are collinear. I told you when the points are collinear, the area of the triangle is 0 or the slope of the line joining those two lines, those two segments, if this A, B, C. Okay, slope of AB and slope of BC will be equal. You can try in that approach. Okay, so that's all for today's class. That's all for coordinate geometry. In the coming class, we're going to discuss the next chapter. Right? Thank you so much, students. Stay tuned to get the next lecture. Thank you.
Yeah. Hello everyone. So now we'll be discussing about power of a lens. Okay, my name is Shashir Reddy. I'm a graduate from IIT Dhanbad. Let's go into the class. So first of all, we'll continue with defects of vision. Right. So in the last class or until now, we discussed about myopia and we discussed about hypermetropia. Both of them are done. But we haven't discussed about presbyopia and cataract, and that's what we'll discuss now. And after that, we'll go into power of a lens. So very quick revision of myopia and hypermetropia. Only the basic points, myopia and you can say hypermetropia. In myopia, what can you see? In myopia, we can clearly see near objects, but we cannot see far objects. You can say that far objects are not clear. Far objects are not clear. Whereas in hypermetropia, what happens in hypermetropia? Near objects will not be clear, but far objects will be clear. So I can say near objects are not clear. Near objects are not clear. So when you talk in terms of far point and near point, here far objects are not clear, that means far point has come closer. Far point comes closer. Whereas in the case of hypermetropia, we cannot see near objects, that means our near point has gone farther. Near point shifts away. Shifts away from the eye. When I say away, away from the eye. Right. And in the case of myopia, image is formed in front of retina. Image is formed in front of retina. Very important but basic points again. Whereas in the case of hypermetropia, image is formed behind the retina. Image is formed behind retina. So all of you should be able to remember these points accurately. Okay. And again, another point that we have, the corrective lens. For myopia, which corrective lens is used? Concave lens is used. Whereas for hypermetropia, convex lens is used. Right. So these are the main differences, or you can say the basic points regarding myopia and hypermetropia. You know all of them. Good. Now let's go into presbyopia. Now we have already learned about power of accommodation, and because of this power that we have, we can easily focus on near objects as well as far objects. We can focus on near as well as far objects. Right, and depends on what this power of accommodation is enabled by ciliary muscles as well as our eye lens because of their flexibility. Right, so as you grow old, what happens is that flexibility reduces. It could be because of ciliary muscles or it could be because of the eye lens itself, but that flexibility reduces, decreases with time. So with age, as you grow old, flexibility of lens in the eye reduces. And ciliary muscles also get weak. This makes it difficult for what? You are losing your power of accommodation. Right, so this makes it difficult to focus on near and far objects at the same time. That means you will not be able to see near objects as well as far objects. So you have both myopia and hypermetropia. The reason is different, old age, but you have both of them. Is that clear? So this makes it difficult for the eye to accommodate near and distant vision, both of them. Okay, so the near point comes closer and the far point comes nearer. Both of that happens. Got it? Good. And how do you correct it? See, we are not able to see near objects as well as far objects. It's like both myopia and hypermetropia. Then we should use both convex and concave lens. So we should go for their combination. That's why we use something called as bifocal lenses. Now what are these bifocal lenses? They'll have two types of lenses. For example, look at this image. Can you see the image here? There are two types of lenses. A better image is given here. Right, so the upper part is for distant objects. The lower part is to look at near objects. Right, so here you can see they have convex lens at the bottom. So this here for near objects we use convex lens, and concave lens at the top for distant vision, for looking at distant objects. Is that clear? Good. Now I'll give a simple example. Have you seen old people using, old people like you can grandfather, grandmother, right, elderly people? When they read their newspaper, they keep their specs in this way, like on the nose. Have you noticed that? Yes or no? Why do they do that? It's not out of habit or out of style. It is necessary because they have to use what? To look at the near objects, they have to look through the bottom of the specs. They have to look through the bottom of specs, so when they keep it on the nose, it will be easier for them. Then they can look through the bottom of the specs. That is the reason. Right, so as you grow old, there are chances of presbyopia. Right, and then we use bifocal lens. Got it? It's mostly because of what? Mostly because of old age. With old age. Good. Then there is another defect called as cataract. That is completely something else. Here what happens is, on your eyes, okay, on your eyes itself, there will be a layer formed. A layer will be blocking your vision. A layer will be blocking light from entering the eyes. Yes, and that layer formation is nothing but cataract. What is that layer? That layer is a lump of proteins. So again, it also mostly happens in old age. Proteins in the eye lens can clump together, making it cloudy or even opaque. And what does opaque mean? It does not allow light to enter. And if light does not enter, you cannot see. Right, so there will be a layer formed, a layer because of what? Proteins in the eye. This leads to decrease or loss of vision. So how do we rectify it? We rectify it by using, it is rectified only by surgery. So through surgeries, that layer can be removed. So cataract is corrected by surgery. It's very common. Okay, it's very common nowadays among old people. Okay, good. So we learned about the defects of eyes, presbyopia and cataract. Okay. Now we'll be starting with power of lens. Before that, let's go into a simple problem here. What is the problem? A student has difficulty reading the blackboard while sitting in the last row. So in the back bench. He's a backbencher, right? So from the back bench, that student is not able to see the blackboard clearly. What could be the defect the child is suffering from? How can it be corrected? Yeah, which defect can it be? That student, he or she, is sitting in the last bench, the back bench, and is not able to see the blackboard. That means that student is not able to see far distance. Obviously, blackboard will be far. So if he or she is not able to see the blackboard, he or she is not able to clearly see far objects. If he or she is not clearly able to see far objects, that defect will be myopia. It will be myopia. And you might be asking, sir, why not presbyopia? In presbyopia also you cannot look at far objects. Agree, but presbyopia mostly occurs in elderly people, old people. But here we have a student. Students are young. So it cannot be presbyopia. It should be what? It should be myopia. And the next part of the question is, how can it be corrected? How do you correct myopia? How? Which lens do we use? Yeah? We use a concave lens. We use what? We use concave lens. So using a concave lens, it can be rectified. It can be corrected. Got it? Good. So now we'll go into power of a lens. Now, for those of you who have sight or who use specs, right, obviously specs has lens. But we don't talk in terms of focal length. We talk in terms of something called as power. Which power or how much power do you have? -1, -1.5, -2, -0.5. Right, we talk in terms of something called as power. So what exactly is this power? Right, so let's understand that. Now let me take a lens. I'll take a convex lens. I'll take two cases. Okay, let's say in this case, the focus is here, and in this case, the focus is a bit far away, somewhere here. Okay. Now, I'll be taking parallel rays. Okay, one ray is enough. I'll take a ray parallel to principal axis. What happens to it after passing through the convex lens? It converges or it passes through a point on the principal axis called as focus. Simple enough. The same thing, I'll again take a ray parallel to principal axis in this case also. And what happens in this case? The same thing happens. Right, it passes through a point on the principal axis called as focus. The question is, which lens, the first lens or the second lens, which lens is bending the ray more? Which lens is bending the ray more, 1 or 2? Yeah, everyone? 1 or 2. Which lens is bending the ray more? Yeah. And the answer is 1. 1 bends the ray more. 1, and say lens 1 bends the ray more. Why? How? Let me explain that. For that, I'll again take a convex lens. Okay. Let's say this is a convex lens. Now what I'll do is I'll take two special cases. In the same itself, In the same diagram itself, I'll take those two cases. Now, this is the incident ray. Let's say this is one case when the focus is here. And let's say this is another case. And if this another case, the focus is here. Okay, so I am shifting what? I am shifting the focus. And when you shift the focus, automatically the focal length also will change. Automatically the focal length will also change. Now let's discuss about that. So let's say this is case 1, this is case 2. And here, if I just look at the bending, now this blue color dotted line is supposed to be the direction of the ray. Now this is the direction of the ray. If there was no lens here, the ray will be going straight. If there was no lens, the ray would have been going straight. But there is a lens, so there is bending. Now see what or which lens or which ray is bending more. Can you see? This is for ray 1 and this is for ray 2. So which ray is bending more? Ray 2 is bending more. And for ray 2 or for ray 1, in which case is the focal length less? The focal length is less for ray 2. Yes or no? This ray 2, the focus is here, so only this much is the focal length. So here you can clearly say a point, lesser the focal length, greater is the bending. You can say convergence, it's fine. Greater is the bending of ray. Clear? See, again, just look at that carefully. We have taken two cases, two different focus, that means two different focal lengths. And we have looked at the bending. In the second case, the bending is more, and in the second case, the focal length is less. So, lesser the focal length, greater is the bending of the ray. Clear? And what is power? Power measures the amount of bending of ray. How much can a lens bend a ray? Okay. So, greater the bending of ray, greater the power. Greater the bending of ray, greater the power, because power measures what? The bending of ray. That is the reason. So we can say that lesser the focal length, greater is the bending, and that means bending is greater will mean greater is the power. So lesser focal length, greater power. Lesser focal length will imply what? Will imply greater power. So what can we say from this? We can say that power is inversely proportional to focal length. Power is inversely proportional to focal length. Lesser the focal length, greater the power. And using this itself, we define power as this. That's it. A very simple definition, straightforward definition. Power is defined as the inverse or the reciprocal of focal length. The reciprocal of focal length. Clear? So let's go into the definition here. The degree of convergence or divergence of light rays. And when we say convergence or divergence, it ultimately means the degree of bending of light rays that can be achieved by a lens is expressed in terms of its power. So the reciprocal of focal length is called power of lens. That's it. Straightforward definition. One simple form definition. This is the definition, by the way. That's it. Power of a lens is the reciprocal of what? Focal length. Now generally, focal length can have any units, and generally most of the questions that we come across will be in centimeter. Right, so depending on the units of focal length, formula slightly changes. Or else you can just remember one formula. Power is equal to 1 by focal length in meters. So if the focal length is in meters, you directly take it as 1 by f. For example, Example 1. Focal length is equal to 2 meters. Then we directly take power as what? 1 by 2. Because focal length is in meters, we can directly use the formula 1 by f. So 1 by 2, it is 0.5. Okay, so the denominator should be in what? Should be in meters. But if I take another example, let's say focal length is 20 centimeter. But what is 20 centimeter? In terms of meter, 20 by 100 meters. Yes or no? So then power will be equal to what? 1 by 20 centimeter, which is 20 by 100. How much is that? 100 by 20. That is equal to 5. That is equal to 5. So look at this. When we are taking it in terms of centimeter, we can directly make use of this formula 100 by focal length in centimeter. Right, that's why we have this formula. For our convenience, we define two types of formula. One is directly 1 by focal length when the focal length is in meters, or 100 by focal length when it is in centimeter. When it is in centimeter. Got it? So very simple formula 1 by f. The only thing we have to be careful is whether the units are in meters or in centimeters. Now you might ask me, sir, what if the focal length is in millimeter? Then just convert that into centimeter, use it, or convert into meters. Or else if you need, you can say 1000 by focal length in millimeter. But mostly you will not come across millimeter, it will be in centimeter. Got it? And one more important point that we have is the SI unit of power is something called as diopter, and the symbol is capital D. And for SI unit, what is the SI unit going to be here? Just look at this. 1 diopter, power is what? We are taking power as diopter, the SI unit. So 1 diopter is equal to 1 by 1 meter. Focal length is also in SI units. 1 diopter is equal to 1 by 1 meter, or you can say 1 diopter is equal to 1 per meter, because meter is in the denominator. So what is diopter? It is the SI unit. It is the SI unit of power. Symbol is capital D. Very, very, very important point, because normally people forget that. That is the reason. Got it? Good. So let's go into a few problems and to understand things better. Here, if a doctor has advised you to use a lens of focal length 2 diopter, what is the focal length of lens? Sorry, there's a slight mistake in the question. It should have been what? To use a lens of power 2 diopter. It should have been to use a lens of what? Power 2 diopter. What is the focal length of the lens? What is that going to be? Let me solve this from next question. I'll leave it to you. So what is given here? A simple power is given. Given information. Power is equal to 2 capital D diopter. But what is power? Power is equal to 1 by focal length in meters. But if I look at the options, see the options 200 centimeter, 100 centimeter, 50 centimeter and 25 centimeters. So what is the unit of focal length? Centimeter. So we need the focal length in centimeter. So what I will do is, here I'll take the formula as 100 by f, but the focal length that we get will be in centimeter. Right? So power is 100 by f, and the power given is 2 diopter. Right? Then just do the calculation. Right? 2 comes to this side, f goes to that side, f becomes 100 by 2, that becomes 50, right? And we get the focal length in centimeters. The focal length is how much? 50 centimeter. How much? 50 centimeter, and hence the answer is what? The answer is option C. Clear? Take it down, very simple. Quickly take that down. Given information, the formula for power, substitute, and we will get it. Done? So we got the focal length. Right. Good. Now we know that for different lengths, right? Like you can take example of concave and convex. The focal length can be positive or the focal length can be negative. Does that mean that power also can be positive and negative? What do you think? And for most of you, in fact, almost all of you, right? For those all those of you who have specs, who have a sight, what is your power? If you look at your prescription, it will be written as negative power. -1, -0.5, -0.75, -1.25. The power will be given in what? Negative terms. That means power can be negative. Yes, it can be negative. And it depends on what? It depends on focal length. So when I say P is equal to 1 by F, F is positive, power is positive. Simple. F is negative, that means what? Power is negative. So whether power is positive or negative will depend on what? Focal length. Easy, right? Very easy? Yes. Good. So now an interesting question based on that negative power and all. The question is, lenses with negative power are converging lenses. Is the statement true? Yes or no? I'll give you 30 seconds of time. Compare it with the focal length. Okay, when you compare it with the focal length, then you will get the answer. 30 seconds of time. Please solve it. Lenses with negative power are converging lenses. Think in terms of focal length. Got it? Ten seconds more. 5, 4, 3, 2, 1, and the time is up. Okay. So here, how shall we do it? And first of all, what do converging lenses mean? What do diverging lenses mean? Right. The best example that we can think of will be what will be a convex and a concave lens. Here, as you can see, these are converging lenses. And which example do we take? We take a convex lens. Right, and this is what? Converging, because it converges the rays. That is the reason. Converging. And here, the focal length is positive or negative? Yeah? The focal length in this case is positive. That means power is positive. Focal length is positive, that means power is positive. Simple. Right? Now, similarly, if I take a concave lens, principal axis, and then if I take incident parallel rays, what happens to them? They will refract in this way or they will diverge. Right? So here, concave lens is what? A diverging lens. Concave lens is what? A diverging lens. And what about the focal length? The focal length is negative. And the power is what? The power will be negative. So what does that mean? What it means is, whenever we have positive power, it will mean a converging lens, and whenever we have negative power, it means a diverging lens. Negative power will mean what? Diverging lens. So keeping this in mind, if I come back to the question, lenses with negative power are diverging. What is mentioned here? Lenses with negative power are converging lenses. Is the statement true? Is the statement true? No, the statement is false. The statement is false. Okay? Good. Next. The same point, the point that we have discussed is given here. Converging lenses have positive power, diverging lenses have negative power. Good. So another simple question for us. What is the focal length of a concave lens Acha, again, a slight mistake here. What is the power? My mistake. What is the power of a concave lens of focal length 25 centimeter? And we have a few options. Okay. So let me give you, how much time? 30 seconds? Yeah, 30 seconds will be enough. Focal length is given. You have to find out the power. So a simple, straightforward question. So please solve it. What is the power of a concave lens of focal length 25 centimeter? It is a concave lens, so you have to be careful. What is the power? Yeah? 5, 4, 3, 2, 1. The time is up. Got it? Good. So how do we do this? The focal length is given as 25 centimeter, but which lens do we have? Concave lens. And for concave lens, the focal length is negative, so f is equal to minus 25 centimeter. F is equal to minus 25 centimeter. That means power is going to be 1 by f, but f should be in meters. Here the f is in centimeters, so we can take 100 by f. Simple. Right? So P is equal to 100 by, what is f? F is minus 25. So minus will remain, 100 by 25 is 4. So minus 4. What about the units? Capital P, capital D. And capital D refers to diopter. So the power is minus 4 diopter. And hence the answer will be option A. Clear? Good. So that's it, everyone. So we have discussed about presbyopia, cataract and power of a lens. Okay, so thank you. Thanks a lot.